Good evening, everyone. Myself Chandana, and our topic is virtual machine demonstration and comparative analysis of operating system flavors. And our team members are Deepika, Jai Kishan, Aditya, and I am going to do abstraction and introduction of this topic. Contents are abstraction, introduction, experimental setup, implementation, output, traits of application of visualization, conclusion. Abstraction. This project explores the use of virtual machine, how to manage, create and analyze the multiple operating system environments. Our project main aim is understanding and difference between architecture, resources allocation, functionality among the major OS platforms like Windows and Linux. Practical experiment demonstration like how to visualize improving and testing learning development efficiency. Introduction. A visual machine is a software which behaves like a separate computer without any main computer. It runs in OS application. Isolated from the OS system, visualization allows you to run in different OS. It is widely used for testing software development and cyber security training. Next topic is continued by my team members.
Good morning, everyone. Myself, Jai Kishan. Today, I am going to explain experimental setup. This explains how the virtual machines work on the both hardware and software requirements. The first one is hardware component. The process should be Intel Core i5 or Ryzen 5 or equivalent. This means that it should be at least i5 or Ryzen 5 computer process system so that visual machine can run easily. Virtual machine can run easily. The RAM should be 8 GB. The 8 GB of RAM that leads to the working of the different processes simultaneously. The storage should be 100 GB free disk space. This means at least 100 GB storage should be required in laptop or computer so that as the virtual machine takes a huge space, the system type 64-bit architecture. As we know that 32-bit architecture is very small, so we need 64-bit architecture. The host OS is Windows 11. This includes Windows 11 or higher version, which leads to the fast running and process of virtual machine. The software requirements are virtualization tool, Oracle VirtualBox. We should download the Oracle VirtualBox initially to start the to run any virtual machines process. The guest operation system, Windows 11 and Ubuntu 24.04 LTS. This is also another operating system which can be Ubuntu 11 or Ubuntu or Windows 11. The additional tools, this means any additional tools also will be also required for this process. This includes VirtualBox, guest additions, task manager, or system monitor. The next will be continued by Deepika.
Good evening, everyone. I am Deepika and I'll be explaining implementation and output. In the implementation phase, we perform the actual setup and testing of multiple operating system using virtual machine. Firstly, we first launched VMware workstation and created a new virtual machine. Then we set an ISO file, which could be either Windows or Linux, to install the virtual machine. Then we allocated resources such as storage space and RAM depending on the OS requirements. Then after that, we installed and configured the operating system within the environment. Then we tested different OS level operations such as file management, process scheduling, and system utilizers to analyze each OS performs. Then finally, we observed CPU memory uses across different systems to compare performance and resource management. Then output. This is the output from my Linux virtual machine. As you can see it, it display the list of running process, the user who owns them, and their CPU and memory uses. Then this output confirms that the Linux OS efficiently manages multiple background process and allocates resources dynamically. Then which demonstrate process scheduling and memory management in action. Then the column shows information like CPU means how much processing power each task uses. Then memory, how much RAM each process consumes, and discrete input and output activity for each process. Then this output was used to compare performance between different OS environments. For example, Linux manages background process versus Windows. Thank you. Next will be continued by Kishan.
So now I'm going to explain trade-offs. This concludes advantages and the disadvantages part. The advantages is we can run multiple OS on one device. No need for additional hardware. Useful for experiments and training. Easy system recovery using snapshots. Safe for testing viruses or unknown software. The advantages we can easily run multiple or different OS on one single device. No need for additional hardware as a virtual machine doesn't require it or uses the current hardware machine. Useful for experimental experiments and training, as we can see how much how each processor or apps runs in how much times we can use. And easy system recovery using snapshot, we can easily recover the deleted part with the virtual machine. The disadvantages are consume significant CPU and memory resource, slower performance compared to native OS, limited access to hardware, a large disk space required for multiple VMs. This disadvantages says that the CPU consumes a large amount of memory, which can be a problem to the other part of the computer, like as we cannot store many resources at same file. Slower performance as memory increases, this leads to the slower in performance and limited access to hardware. Only GPU and USB will be will be used as the hardware component. Large disk space required for multiple VMs. This says that virtual machines require large amount of disk space to download and run through it. The next will be continued by Aditya.
Now I will explain about the application of visualization. First is cloud computing. Visualization allows multiple virtual servers to run on the single physical server. Next is software testing and development. Developers can create isolate virtual environments for testing software without affecting the host system. This makes the development safer and easier. Next is cybersecurity labs. Virtual machines are used to stimulate real networks and systems for ethical hacking and cyber security training. Next is education and research. In academics and research institutions, visualization enables running multiple OS environments on the same hardware for teaching, experiment, and simulations. Next is server consolidation and backup. Multiple physical servers can be combined, consolidated into fewer machines, running several virtual servers, saving space, power, and the cost. Next is future scope. Integration with AI for smart resource allocation. AI can be used with virtualization to automatically allot computing resources based on the workload demands, improving efficiency. Next is lightweight virtualization using containers. Container technology like Docker provides faster, lightweight alternative to traditional VMs, enabling quick development and portability. Next is cloud-based virtualization for scalable systems. Future systems will increasingly rely on cloud visualization to scale resource up or down dynamically as per user demand. Next is enhanced support for GPU-based workloads. Next slide is conclusion. Virtual machines provide a cost-effective and efficient way to explore multiple operating systems with a single hardware environment. Throughout this demonstration, the differences in CPU scheduling, memory management, file system, and user interface between OS favors very clearly identified. Virtualization enhances learning software, testing, and research without risking the host system. The study proves that Linux are resource efficient and flexible, whereas Windows systems are user friendly and widely compatible. Virtualization technology continues to evolve, forming the backbone of the modern cloud computing and DevOps infrastructure. Thank you. ರೆಕಾರ್ಡಿಂಗ್ ಆಗೈತೆ ಇಲ್ಲ?
ಹಾಂ ಹಾಂ
ಶೇರ್ ಮಾಡಿ ಹಂಗೆ ತೋರಿಸು, ಸ್ಕ್ರೀನ್ ಶೇರ್.
ಬರ್ತಿಲ್ಲ, ಅಲ್ಲಿ ಇದು ವಾಟ್ಸಪ್ ಓಪನ್ ಆಗ್ತಿಲ್ಲ.
ರೆಕಾರ್ಡಿಂಗ್ ವಾಟ್ಸಪ್ ಹಾಕಲಿ.
ಹಾಂ, ಇವಾಗ ರೀಡೇ ತೆಗ್ದೆ ತಾಳೆ.